Welcome to Ask and Learn.
Hello, we're going to be talking about why solid phases of elements, or let's say molecules, are denser in general than liquid phases, and why water is the exception. So let's think about that for a second. Why are solid phases dense, sir? Let's start with that. Solid phases. So I'm going to draw two diagrams of liquid phase of element N. That looks like a, oh, that's horrible. It's not good. Let's try that again. We have a beaker of sorts, and it's filled to the brim with some red liquid that looks like lava. This is all liquid, and this is a representation of how you probably know how the liquid phase looks like at the molecular level. Now, if we were to freeze this up and we have a solid, it will look something like this. We have, and this is a zoom in. The molecules arrange themselves, or elements, but we're going to be talking about water, so we're going to stay with the molecule terms. They arrange themselves in a very neat, like array like structure, where each molecule is densely it's not right. Densely dense. How do you spell the word? Each molecule is densely packed to one another because they have low kinetic energy, and because of that, they want to move less. And so, because each molecule seeks to release its to find the most energy, the least energetic state, they arrange themselves in this array-like structure in order to settle in and move as less as possible. Now, when we talk about water, things get different. So we do have the ocean over here in a beaker. It's a horrible beaker. We do that. We have a beaker. That's better. And we have our lake over here. So things look similar. However, when we freeze it up, it also forms, this is an ice cube now, it also forms this array-like structure. However, when it freezes up, water freezes up with oxygen as well. So this is a very crude depiction of how it would look like, but we have oxygen oxygen, molecules frozen up in between of the water molecules. Now, technically, if you were to freeze water in a vacuum, you would form a perfectly airless, and this is not just oxygen, this could be air, by the way, but I was saying that if you were to freeze up water in a vacuum, technically you would not have air in between the water molecules freezing up with the ice cube. However, as we see on Earth, this is actually less dense because there's a gas mixed into the water, and the polarity of water, the polarity of oxygen with the hydrogens, the H's over here. The polarity also helps with the polar end of the oxygen, of hydrogen, and the positive hydrogen end helps to attract a oxygen atom right in between. Okay, thank you for listening, and good luck. What are you doing? Yeah. A fridge, we can transfer the bottle. Do you have a? Do you have no? I'll do it. I'll help you. Do you have